Hey guys, let's discuss new design today, which is called AI-powered payment system. Okay, so similar to Stripe and Razorpay, we need to design. So here it should be scalable and reliable. Okay, and then user it should support UPI payment like Google Pay, Phone Pay, cards, credit card, debit card, and net banking. Okay, then high throughput like 10,000 to 100,000 transaction per second it should handle. Then no double charges. Okay, and then strong consistency for money. So for a strong consistency, we will be using async property, means SQL database. So this one will be hybrid. So somewhere we will use NoSQL, somewhere we will use SQL. So now what will be the assumptions here? That see, the very first thing is here we are creating payment gateway and not the wallet. Okay, so we will not store the money. We don't store money, just process it. And this one will be India focused UPI. Okay, that is the important thing. And external PSP handle actual transaction. Who is PSP? External PSP, so payment service provider. Okay, Visa, MasterCard, so they will handle the actual transaction. Now functional requirements, so core requirement, user requirement, merchant requirement. Okay, and then system requirement we will see, and then AI feature we will see here. So core requirement, if you talk about, so the very basic is that create payment. Okay, then after that process payment via PSP. Now track status like payment created, processing success or failed, so different status for that payment. Okay, and then idempotent API, means no duplicate charge. So means if user is doing transaction, it should not happen twice, or if he is doing twice transaction, the result will be same. Okay, so no extra charge, duplicate charge. How we will do that, how we can achieve that, we will see later in this document. So now user should view his payment status or history, and merchant should receive the money and then refund also. Okay, it should support full or partial, and then settlement reports also at the end it should generate. Now settlement flow, if you see, so see, first payment collected are settled to merchant T+1 cycle. T+1 cycle means T means transaction day, and T+1 means next day. Okay, next day of the transaction. So it should settle, okay, transaction by that time, and then batch job aggregates successful payments. Okay, so one by one you cannot process the payments, like, so here we will be using batch jobs. Okay, which will take a few payments and then we'll mark that, and then after that transfer money to merchant bank account. Okay, and then generate settlement reports. At the end it will generate reports that your transaction is settled. Okay, now system, if you talk about, so system handle webhooks, async, PSP updates. So it means that you're using third party payment gateways, right? And so they will settle the transaction, and using webhook they will inform you that this transaction is done, and asynchronously, so user doesn't need to wait for that, or our system flow, application flow will not wait for that. Now retry failed payments, if there any retry failed. Okay, so any payment failed, so our system should do retry. Okay, should be able to do retry, and then reconciliation with PSP. So reconciliation means we are checking that whether our system and PSP is on same level or not. Okay, so now here AI feature, so AI feature, what feature we can include here? Okay, this is the new thing. So real time fraud detection, risk scoring for each transaction. Okay, you just add risk score. If it is risky, then don't just block that transaction. And then smart retry strategy based on failure pattern. Then intelligent PSP routing. Okay, choose best PSP dynamically. We can have multiple PSPs, and dynamically we will choose the best one. Okay, which will have low latency, which will have low cost. Okay, low and load is minimum, so we will check that. We'll choose that. Now anomaly detection on transactions. Okay, these all feature we can achieve through AI here. Now API design, if you talk about, so you will have API / payment. Okay, which will be of post. Now here the main thing is in header we will add idempotency key and unique key. Okay, so this one will be your key and value. So why this is important? See, every transaction will have unique key. okay, unique key for this idempotency key attribute. And whenever user is doing double transaction, he will check, system will check that this is coming twice, okay. So he will just process one, and for second it will return the same result. So here your request will be something like this: user ID, amount, okay, currency, method, and idempotency key we pass through header. So now response you will get that, okay, payment ID is this one, okay, this is successful, status is created. Right now it is created, and after that it will go to multiple stages. We will see that, okay, either it is successful or retry or timeout or failed, okay. So like that. Now here the next API will be get payment / ID, okay. So you will check particular payment ID information, like you got this payment ID na? So you can see the status of that or the information about that payment ID. Then next API will be payment ID and refund, okay, so which will be of type post if you need to refund it. And then webhook PSP, so that is also type of post, okay. Now non-functional requirement, so here scalability, okay. So your system should handle 100,000 transactions per second. Now availability, 99.99% your system should be available, no downtime, okay. Then consistency, so we will maintain here one ledger, okay. So whatever, this is the single truth, single source of truth. So here whenever you are doing any transaction, we will maintain that ledger. So in that ledger you would be required a strong consistency. Otherwise for UI we will be using eventual consistency. We will check this ledger in this video only, okay. Now latency should be less than 200 millisecond, okay. Initiation means less than 200 millisecond the response should come. And then reliability, so no money loss and no double debit. So using idempotency key we will achieve that. Now security, here we will be using PCI-DSS and encryption, okay. So now and auditability, so full trace of transactions. So whenever we need to do any audit for this, we should have all the trace of the transaction. Now what is ledger here? Ledger is the system of record that tracks all money movement, okay. So ledger is the single source of truth for balances and transactions. What is PCI-DSS? This is very important, okay, very interesting also. So PCI-DSS is your payment card industry data security standards. So it's a security standard that any system handling card payments, okay, credit card, debit card, must follow. So if your application is handling card payment, then you need to follow this rules, okay, rules which is defined here. Otherwise your system will not be compliant, and then you have to bear charges and everything, legal issues and all, okay. So now here it's defined by a major card network like Visa or MasterCard. PCI-DSS ensures that the cardholder data is stored, processed and transmitted securely, okay. Security is main. Now when does it apply? So if your system accept card payment, store the card data or processed card transaction, anything related to card information, okay, you need to provide security there. So then PCI-DSS compliance is mandatory for you. Now what is card data? So card data will come like card number, okay, and then your CVV, expiry date, cardholder name. So all this detail will come into card data. Key PCI-DSS requirements, so don't store sensitive data, okay, like CVV number, or avoid storing full card number. Then you provide encryption, okay, data must be encrypted. So if it is in transit, it is going from one server to another, so use HTTPS or TLS. And then if it is at rest, that time also you need to provide encryption. Now access control, so only authorized system or users can access data, okay. After that monitoring and logging, so track every access to card data, who is accessing it, and regular security testing. So here we will be using vulnerability testing and penetration testing. What is penetration testing? Pen testing, okay. So here pen testing is simulated cyber attacks on your system to find security weakness before real attackers do. Now in payment system design, okay, when we say security, PCI-DSS encryption, so it means that we don't handle raw card data directly. We rely on PSP like Stripe and Razorpay. They are already PCI compliant, okay. So we will not store that information. So these PSP will store the information. They will give us token, encrypted token, and we will store that. So we will not have that data access. real world approach. Okay, so instead of storing card data, use tokenization. So here card detail will go to PSP, they will provide you token and your system will store the token. So your system never see the actual card number. Level of PCI compliance, so level 1 and level 2, 3, 4. 1 usually used by the large companies who is using millions of transactions, and 2, 3, 4 are used by the smaller systems. Now why this matters? See, if you violate PCI, then you have to bear heavy fines, legal issues and security breaches. Now high level architecture, if you see here, so this is the one. Okay, now here user will use your application through mobile, web, okay, or any third party system. Now here this is the request will go to API gateway, which will handle your authorization, authentication, rate limiting and request validation. All these things will happen here. After that your payment service come into the picture. Okay, and payment service will have your will create the payment for you, get status, refund, okay, webhook receiver, idempotency, validation and business rules. All these things is listed here in this payment service. After that so here you can see that once the payment is created, okay, and it's sent to PSP. So here is the different state machines, you can say. So first payment will get created, then it will be processing, okay, after that it will be successing, or it can failed also, or you have to retry if it is not successful, then in that case. Now you will have a PSP adapters through which you will connect to PSP providers. Okay, now here Razorpay, Stripe, Paytm, okay, and then you will have a bank UPI or external PSPs. You will connect with them through adapter, and then they will provide you webhook services. Okay, through webhook services you will change the status of your payment from the database. Okay, and then also you will maintain the ledger service. You will maintain all the record of the transaction, and then you will use DB asset property for the transaction management. Here few more things you can see, that cross-cutting concerns, which is common for all the APIs, you can say. Okay, is the security, and then monitoring, logs, and then audit and logs, okay, and then fraud detection as well. So AI will come into picture here. Now here you can store the data in Redis, okay, and then you can store the data in Kafka also. Okay, so if there are hundred thousands of transaction is happening, so you cannot handle without messaging queue, right? So we have to use messaging queue for the async communication, and then persistent storage you will be using here. Okay, this thing. So this is the overall flow architecture of this system. Now here if we talk about AI, artificial intelligence, so here AI risk engine, let's talk about risk engine here. Okay, so risk engine evaluates each payment before processing. First means of course you have to evaluate it before processing only, right? And then generate risk score from 0 to 1. So what input feature it will take? It will take user history, transaction amount, okay, device IP or location, okay, through location also, payment frequency and past fraud pattern. So all these things it will take as an input feature, and then output what it will give you, it will give you risk score. Okay, and then decision, either he has to allow it, block it, or step up authentication like OTP or two-factor authentication is required or not. Okay, he can ask you that as well. Now payment flow, if you check here, so see, user clicks pay 1000 rupees. Okay, so now this post/payment API will get called, and then from there system will create the payment record and generate idempotency key. So this one will happen, this step will be at your application level. Now here, from here it will call AI risk engine. Okay, so if risk score is greater than threshold, so he will block it, or require extra verification, okay, through OTP or something else, 2FA. Otherwise it will proceed to PSP. Now user approves, so this one will go to PSP. User approves UPI app, okay, and approves it in UPI app, and then PSP sends webhook. Once it is completed, PSP will send webhooks, and it will have the status of your request. Okay, so here update status is successful, and then write ledger entries and notify user. Okay, so here ledger is very important. Now core problem or double payment. So here the most the main problem is double payment. Okay, and we will handle that using the idempotency key. which we will send in the header section. Okay, so the same thing is written here. So like solution is idempotency, same request, same response, no duplicate charge. Okay, so like we will use unique idempotency key, and one more thing you can use on DB level, you can use the constraints. Okay, unique constraint, and caching also we can use here. So now concurrent handling, okay, like two requests are at the same time hitting. Okay, so in that case use DB unique constraint on idempotency key, and then use select for update. Okay, so using this select for update, you avoid the race condition. It will give the create a log on a row level, okay, in your database. Now optional, so in Redis distributed log, okay, you can use that for high contention. Now example is two parallel requests, so only one will succeed and other will result the same response. So what does select for update means? So it's a row level lock in SQL. Okay, so when you read a row using for update, the database logs that row, so no other transaction can modify it until your transaction finishes. So now database design, if you see, you will have a payment table, okay, which will have ID, user ID, and then amount, status of the payment, idempotency key, this is very important, and created it. Okay, and then that too unique, you can see this. Okay, so database level constraint we have used here. Now payment attempts, okay, so payment attempts, how many times he has attempted that payment. So ID, payment ID, status, okay, then PSP reference ID, this one will be your PSP reference for which PSP you have tried it, and then created it. Now ledger, okay, this is the source of truth. So ledger entries, you will have this ID, account ID, amount, type, reference ID, and created it. Okay, so now here SQL reference ID will be unique. Okay, from SQL side, if you see here, reference ID will be unique for this ledger. So ledger idempotency, each ledger entry has unique reference ID. Okay, so this one will be unique. Prevent duplicate debit or credit during retries. Now account table you will have, so which will have the ID, user ID, and balance information, and user behavior, this one we will use for the AI purpose. Okay, so here you will have user ID, average amount, then transaction count, last location, and device ID. Okay, for the user behavior we will be using this table. Now state machine, we have already discussed this, that first your payment will be created, then it will go into the processing state. From processing, either it can fail, okay, or it can success, or if it is unknown, like timeout happens or something, so retry will again happen here. Okay, now if you talk about low level design, like in Java, so here you will have one payment service. Okay, so payment service will have one method create payment, which will take request as an input and will return the payment response. Okay, now what it will do, first it will using the key, okay, using the key it will check whether it is the existing transaction or not. Okay, if it is existing, then you just return existing. Okay, you don't need to proceed it, because here we will be working on the unique one only. Now otherwise it will create payment, it will set the status to created initially. Okay, I told you initially it will be created, and then it will save that payment into repository, and then will call orchestrator process method, okay, through that using that payment, and then at the end return payment. So here orchestrator, like payment orchestrator class, what it will do, it will have a process method which will return you void. Okay, and then it will take payment as an input. Again here it will set the status to processing, now it is processing. Okay, and then it will call the PSP pay method using that payment. Okay, and then will store the response. If response is successful, then it will make entry into the ledger. Okay, and then will set the status to success, otherwise it will set the status to failed. And if anything happen, like timeout happens, so it will set the status to unknown, and then it will retry that payment. Okay, now ledger service here, so ledger service you can see you will have a post entry method which will return you void and will take payment as a input. Okay, so post entry means when it is successful, in that case you have to make two entries, one for credits, another for debit. Let's say I am transferring amount in someone's account, so it will be debited from my account and credited into that person's account. Okay, so that entry we will be adding here using this new entry debit, new entry credit. Okay, so this is called double entry accounting, means maintaining debit and credit. So distributed transaction handling, here definitely this is distributed transactions. Okay, so here you will be using Saga, and you cannot use 2PC because your external PSP cannot participate, okay, and it is not scalable also. So in Saga pattern, it is orchestrator based pattern, okay. So each step in PSP call, ledger, update is independent. On failure, compensating action will happen, like refund will happen, okay. And Saga and 2PC I have already discussed in my earlier videos. Now failure handling, how you will handle the failure here, okay. So let's say if PSP is timeout, okay, in that case we will mark it as unknown and retry it, okay, using the same idempotency key, and wait for the webhook, okay. Webhook will come from PSP. Now if webhook delay, okay, that webhook itself is taking time, in that case we will poll PSP API, okay. We will again call the PSP API and reconcile later. So later we will adjust it. Okay, now DB failure after debit. So debited, okay, the amount is debited from your account, and then DB failure happened. Then what will happen? So in that case we will use the transaction. I told you that we will be using here asset property for the transaction, and we will retry it, okay. Ensure idempotent ledger writes. Now AI based PSP routing, okay. If you talk here, so you can have multiple PSPs, and AI will dynamically choose the best PSP for you. Choose PSP dynamically using ML model feature. So what feature it will use? You know that whenever you are running ML model, it will take feature, okay, from raw data. We will create a features, and it will use that, it will store that feature into feature store, and then will that feature store, from that feature store, these features we will give to ML algorithm, ML model, and then it will train itself, and then will return you the it's a decision. You can call it as input inference, okay, real-time inference, and then real-time it will take some action, whether you have to block that or allow that. Yeah, so next is features. So features we will be using here for AI is your success rate, okay, your success rate, latency, cost, and historical reliability. Now example, Razorpay success rate low, okay, so route to Stripe. Now reconciliation, if you talk about here, so reconciliation means verifying that your system record matches the actual transaction processed by the PSP or by the bank, okay. So daily job, you will run daily job there, and then that job will compare system records with PSP reports and fix mismatches. Now here scaling strategy, if you talk about, so scaling your system should cater a large request, right, large number of requests. So in that case it should be a stateless service, okay, so auto scale. If the number of requests is more, then it should add the servers, and similarly if it is lesser, then remove the servers. Now Kafka for async processing, Redis for caching, DB for sharding by user ID, and read replicas we will be using here for scaling. So now here observability, so what all things we will be observing here. First one is metrics. So metrics will be like payment success rate, okay, your success rate of the payment, and then latency P95, P99. So like for initial 95% of the request, it should serve in 100 millisecond, for next 95%, and then for next for not next for the 99% request, it should be handle the latency should be less than 200 milliseconds, something like that. Then failure rate per PSP also we will be maintain, okay, as observability. As part of our observability, then logging, so end-to-end payment trace, okay, on the basis of payment ID. Then alerts, so spike in failure and PSP downtime. For this we will be sending alerts. AI monitoring, so model accuracy, okay, how your model is working. False positive, blocking legit users, okay, so that would be a false positive cases as well, right, means model has predicted something which is wrong, so that also we will monitor how many times it is giving that. And then drift detection, okay, so means if there is any mismatch. Now feature store, so feature store stores historical user, okay, and then transaction feature. Example, average transaction amount, payment frequency, and device history. Model training pipeline, so here we will train ML model on historical fraud data, and periodically retrain the model. Okay, online inference, so real-time scoring during payment. Now security and compliances, if you talk about here, so we will be using PCI-DSS compliant. It should be PCI-DSS compliant. We have already discussed it. Tokenization also we have discussed. We don't store any card detail. Okay, the other like bank or someone will give us the token and we store that token. Encryption, we will be using TLS there, and then audit logs. Now fraud and rate limiting we will be using here. Okay, rate limiting per user ID or IP or API, and then AI based fraud detection also we will be using here. So ML model detects unusual spending behavior, device fingerprint anomalies, location mismatch, and transaction pattern deviation. All these things, if it is there, AI model will detect that. Okay, and then it will detect the fraud. Example, user normally pays 500 rupees but suddenly he is paying 50,000, so that is a flag. Now trade-off, if you talk about here, see, trade-off is if you choose one, you have to sacrifice other. So for example, if ledger system you are choosing, okay, so that is accuracy. Okay, benefit is accuracy. You will have the each transaction entry there, but write overhead, you have to write every time in ledger, right? Async processing, so yeah, you can scale your application, but this is complex as well. Okay, you are introducing queue there, it will be complex. Idempotency, so idempotency, the safety will be there, but storage would require here. Webhooks, if you talk about, so webhooks will be reliability, will provide you reliability. Okay, but it will be eventual consistent. AI fraud detection, prevent frauds but false positive also it can give you. Then smart routing, so higher success rate but complexity it will increase. Okay, then real time scoring, so better decision but latency overhead is there. Okay, so now let's talk about one example scenario. Okay, let's say user pays 500 rupees, so payment created, PSP call. Now user approves, webhook received, ledger will maintain user debit and merchant credit, and then status will be successful. That's it. This is normal flow of payment service. So in payment system, correctness is greater than availability. Okay, it should be correct. It's okay if your system is not available, that's fine, but whatever transaction it is doing, it should be correct. Okay, so that's why ledger plus idempotency and reconciliation are critical here. So that's it. Thank you.